Sup, Mr. Lee here. All right, so this practice is going to involve transformations. Um, we're only going to look at the translation transformation. Okay, so I have my notes here on the right. We have all these different types of transformations, as you guys should know. We're only going to focus on how the function changes in its equation and its graph when we work on the translations. Okay, so the translation can be up, down, left, or right, and that'll change the equation accordingly. All right, so here's our example. The graph of h of x is a transformation of the graph of g of x. Okay, so take your time with the wording here. That means that g of x is the original, and then h of x is the transform function. Okay, so we're actually starting at g, which is the purple, and then ending up in the blue, which is h of x, because they tell us h of x is the transformation. Okay, so they give us the equation for g of x. That's our original. We want to write an expression for the transformed h of x function. Okay, so I'm actually going to just start with g of x being written. Okay, that's kind of my baseline. So I just copied it over. It's negative parentheses x minus 1 cubed. And let's figure out graphically what's happening, right? I like to use this point as kind of your main locator point, you can say, right? But really you can use any point as long as you know where the transformed version of that point ends up, okay? So usually this is the nicest point to pick for a cubic function. That's where it, kind of changes directions. If you have your parent function, it's going to be the origin, okay? But this one starts at 1, 0, so the shift should definitely be to the left, right? 1, 2, 3, 4, 5, 6 units to the left, okay? Let me count that one more time. Just be careful. 1, 2, 3, 4, 5, 6. Yeah. So we know graphically that from going from g of x to h of x, we're just going left 6. Okay, so now we have to figure out how that changes our equation. So I'm going to go to my handy dandy notes here. If we're going left 6, that means I have a horizontal translation left of 6 units. Okay, so that means inside of your function, right? Inside of your function, we're going to add that number of units inside. Okay, so this says plus c, right? We went left 6 units, so we're going to add 6 inside here. Okay, so a really simple way to do it is just like this. Inside your cube plus 6. All right, we can simplify this. I'm wondering if Khan Academy will actually accept your answer like this. I'm kind of curious. Let's see. So Khan Academy does accept it, okay? If we wanted to, we can change this to an x plus 5, right? You just simplify the negative 1 plus 6 in there, becomes an x plus 5. But I took the original function, and then inside of your cubic, right, that's the parentheses, you add the 6 there, because we know it went 6 left. Okay, let's try another one. All right, so we have the graph of y equals absolute value of x. So this should be a parent function. And they're asking which of the following is the graph of absolute value of x minus 3 and plus 2. Okay, so your parent function is the absolute value. So you want to ask yourself what's going on inside the absolute value and what's going outside. What's going on outside? They're both some form of adding and subtraction. So inside we have a minus 3, right? So that means we're looking at a horizontal translation. This is a minus c. We have a minus 3, which means it should have gone 3 to the right. Okay? So we're going to make a mental note of that. 3 to the right, and then your plus 2 is a k value. Well, we're using k if you have your standard variables. In this case, it's a plus d. Okay, so we're adding a 2 here, a plus 2 on the outside of your function. So that means after the absolute value is closed, right? You're adding a 2 on the outside, which means it goes up 2. So our conclusion, we should be moving this function right 3 and up 2. So all you have to do is figure out from this parent function, and we can use the origin as kind of your reference point, which one goes right 3 up 2. The only option should be this one, right? Imagine your origin was there, plus 3 to the right, plus 2 up. There's your C. Okay? So let me try to show you the equation along with the the graph. Okay, and we'll do one more. These videos will be a little bit longer. Transformations take a little bit more practice. Okay, so stick with it. Let's show one more here. All right, the graph of y equals g of x is a transformation of your f of x. So read it carefully again. That means f of x is your original and g of x is the final. Okay, write a formula for function g in terms of function f. So this is an example where you don't have the actual equation of f of x, right? You're just writing g of x in terms of f of x. But as you guys will look on these notes here, that's essentially how your default notes actually write the function anyway. Okay, so we're going to still follow this and get our equation for g of x. So f of x is just f of x. So I'm going to start with that. Okay, we're going to change f of x somehow based off the transformations from f of x to g of x and then add it to our equation. So we're just working on translations. So I'm going to use this as my locator point, right? So I'm going to count very carefully. It looks like this minimum point for your f of x function is going to then translate to the minimum point of your g of x function. So I'm referencing this as my new transform point, right? So I'm going from here all the way to here. Let's count carefully. We're going left, 1, 2, 3, 4. And then down, 1, 2, 3, 4, 5, 6, 7. Okay? So you can do them separately, which I will. Let's do the left 4 first. Okay, left 4, I'm going to reference right here. We're going left 4 units. So we're going to go plus 4 on the inside. So on the inside of your function, plus 4. All right, that means I'm taking f of x and moving it left 4. And now I'm going to go on the outside of the function. What did I count? I went down 1, 2, 3, 4, 5, 6, 7. So down 7, it's going to be a vertical translation. I'm going to subtract on the outside of my function now 7. Okay, so make sure you position all your numbers right. This will be f of x plus 4 minus 7. Okay. There we go. So give those a try. Actually, I just paused the recording, but then continued. I think it'd be good to actually finish this all the way through. So again, longer video, but transformations, they naturally just kind of take a little more practice. Okay, so stick with it. Here's a good graphing exercise. Okay, so the graph of the function of f of x equals x squared is shown. That's going to be this parent function, right? Hopefully you know your parent function for your quadratic. That's y equals x squared. And then we want to graph this g of x using the blue graph and the 2 green points. Okay, so let's figure out from the equation what the transformation is first, and then we'll move around some points. Okay, so your default parent function is x squared. So on the inside of your square, before you square it, we have a minus 2. Okay, so let's match it here. Minus 2 means it should be translated to the right 2 units. Okay, so let's actually do that separately here. So here's my default parabola. If I move everything to the right 2 units, we're going to get to here. Okay, I'm doing one step at a time. So this is just the first step of if I added this minus 2 inside the parentheses. Okay, so now I have to deal with the minus 4. This minus 4 should be a what? A down 4. Translation down 4, right? Minus d on the outside, minus 4 on the outside, which means now I move everything down 4. Okay, so we can only move one at a time. It's going to look kind of funky, but we'll just follow it. So move this down 4. If I can click it, 1, 2, 3, 4, and then move this one down 4. 1, 2, 3, 4. Right? You should be able to see it's the same, shape and size from the parent function. Right? All we did is a translation of this one. So to the right 2 and down 4. That should be good. Now try them.